This is 1-4, solving two-step and multi-step equations. So what you want to know about multi-step equations is it takes more than one step to isolate the variable. So what I like to do is I actually highlight the variable and its coefficient. And now I need to isolate that x, but I really have two things happening here. I have multiplication by 11 and I have a subtraction of 4. What I want to do is stay away from this 11x right now. And I'm going to get rid of that subtraction of 4 first. So I'm going to add 4 to both sides. And I end up with 11x equals 33. Now to get the x by itself, my last step would be to divide by that coefficient. So I can divide both sides by 11 since that was multiplication there. And x equals 3. And I can plug that back in to check my work. So 11 times 3, our x is 33, minus 4 is 29. So x equals 3 is correct. Okay, our next one, what I want to do here is I want to eliminate that fraction first. So to get rid of that division by 5 and make this look like an easier problem, I'm going to multiply both sides by 5. And now I have a plus 7 equals 25. From there, I'm solving for a. So to get rid of that plus 7, I'm going to subtract 7 from both sides. And a equals 25 minus 7, 18. Okay, so I can plug that in. If I put 18 in here, well, 18 plus 7 is 25, divided by 5 equals 5, so this is correct as well. Okay, same thing for example 2. It looks confusing because we have fractions, but if I highlight my variable with the coefficient, which is really 1/26, and I want to get rid of that minus 1/13 first, so I'm going to add 1/13 to both sides. These are already common denominators, so this works out kind of nice. So x over 26 equals, well, 3/13 and 1/13 is 4/13. And my last step to isolate x is to get rid of the division of 26. So I'm going to multiply both sides by 26. Remember, 26 is 26 over 1 if we want that as a fraction. And I can cross simplify. 4 over 1 is simplified, but 26 over 13 can divide both of those by 13, and we end up with 2 over 1. So I'm going to multiply straight across. 4 times 2, which is 8, over 1 times 1 is 1, but we don't need that, so 8 over 1 is just 8. And I could plug this in and make sure that this works as well. So if I plug in 8 here, 8/26, well, that's not simplified. Let me simplify this. So divide both sides by 2. Both numerator and denominator by 2. And I end up with 4/13. Well, 4/13 minus 1/13 is 3/13, so this is correct. Okay, same thing in the next problem. So we've got 3/4 y, it's my coefficient with my variable, and I need to get rid of the plus 1/2 first. So I'm going to subtract both sides by 1/2. Yeah, we do not have common denominators, and we need them when adding and subtracting. So 7/8 minus 1/2, that's not going to work. I need this 1/2 to have a denominator of 8. Well, you can make your life easier. What divided by 8 is 1/2? Well, 4 divided by 8. Or you can think to yourself, how did I get from 2 to 8? I multiply both sides by numerator and denominator by 4. And so it's 4/8. So 7/8 minus 4/8, which is 3/8. So I have 3/4 y equals 3/8. Now, again, we have a couple options. We can either multiply by the reciprocal, or we can multiply each side to eliminate the fraction by 4, and then divide by 3 after that. I'm going to try multiplying by the reciprocal. So instead of 3/4, it's going to be 4/3. Now, keep in mind, this works, by the way. I didn't really say this before, because it's cross-simplifying. 4 over 4 becomes 1 over 1, and 3 over 3 becomes 1 over 1, and so we end up with 1y, which is what we wanted, 1y. Okay, so we're going to multiply the other side by 4/3. Cross-simplify. The 3/3 becomes 1 over 1. The 4/8 becomes 1 over 2, and so y equals 1/2. Okay, sometimes we end up with situations where we're supposed to do parentheses first, but we cannot add what's in the parentheses, like in this example down here, x plus 6. Those are not like terms. So what we can do instead, since the 5 is touching the parentheses, that's multiplication, we can multiply the 5 to both terms. And so we did 5 times x, which is 5x, and 5 times 6, which is 30. Okay, so what we want to do always is try to simplify the best we can on each side of the equal sign. So for instance, if I look on the left-hand side of this equal sign, I've got a lot going on. I've got a 2a plus 3, that's a constant, and a negative 8a. Well, the two that I highlighted are like terms, 2a and negative 8a. We can combine those. It'd be like saying 2 apples and negative 8 apples, which would get us negative 6 apples, negative 6a. We still have that plus 3 equals 8. Now the right-hand side's already simplified. It only has an 8. There's nothing I can do to that. So now I'm solving like normal. So I've got my variable with its coefficient. So I'm going to get rid of that plus 3 first. I'm going to subtract 3 from both sides. And I get negative 6a equals 5. Now from there, to isolate a, it's multiplying by negative 6. So I'm going to divide both sides by negative 6. And I get that a equals, this is already a simplified fraction, so negative 5/6, or negative 5/6. Okay, in example 3b, I see those parentheses again, so I'm thinking parentheses first, but these are not like terms, so what I can do is I can distribute this negative, which is really a negative 1 that's being multiplied, to both terms. When you multiply by a negative, you're really switching the signs of them, so that 3 is going to become negative 3, or negative 1 times 3 is negative 3. Negative 1 times negative d is positive d, or you just switch the sign of the negative d, equals, and the 4 remains the same, so I just did what I could to the left-hand side. Now I can't simplify this anymore because there's nothing to really combine here, but what I can do is highlight my variable, the d, and all I need to do is get rid of that negative 3 to isolate it. So I'm going to put a positive 3, I'm going to add 3 to both sides. And so I get d equals 7. Now keep in mind, we could still check our work with these. So if you plug a 7 in right here, well, 3 minus 7 is negative 4. But then I have a negative 4, or negative times a negative 4, which changes the sign, so it becomes a positive 4. So this is correct. Okay, we've got a little bit more going on in example 3c. So what I see first again is my parentheses, but I can't do x minus 2. So what I'm going to do is distribute that 4 to both terms. 4x, and then 4 times negative 2 is negative 8, plus 2x equals 40. Okay, on the left-hand side, it looks like I can still simplify some more. I've got 2 of the same variables, 4x and positive 2x. Well, 4x plus 2x is 6x. Don't forget that minus 8, or negative 8, equals 40. Now, my variable's right here, that's 6x. So what I want to do now is get rid of that minus 8, so I can add 8 to both sides. And I get 6x equals 48. Now to get x by itself, to get rid of that multiplication, I'm going to divide both sides by 6, and I get x equals 8. And again, we could still check our work. So if I go back and do my parentheses first, I would put my 8 right here, in parentheses 8 minus 2 is 6, 6 times 4 is 24. So now I have 24 plus 2x equals 40. Well, I have to put the x in here as well, and that's 8. So 24 plus 2 times 8, which is 16, equals 40, and then I get 40 equals 40. So this is correct as well. You can always check your work. It's going to build your confidence in this class. Okay, example 4. Tony is buying skis that are on sale for 2/3 of the original price. I already see a keyword here, of the original price. After he uses a $25 gift card, the total cost before taxes is $115. What was the original price of the skis? Write an equation for the problem and then solve that equation. So my variable is going to be the original price. I'm going to call this my x. So I'm defining my variable first. Then from there I have 2/3 of the original price, so multiplied by x, minus the $25 gift card that he's already used, gives us a total cost, or equals $115. Okay, and so we can solve, put some dollar signs here so I remember what I'm solving for. Again, I'm going to highlight my coefficient and variable, and I need to get rid of that minus 25 first. So I'm going to add 25 to both sides, and I get 2/3 x is equal to, well, 115 plus 25 is, let's see, 25, 35, 40, 140. Okay, and I have two options now. To isolate x, I can either multiply by the reciprocal, 3/2, because I'm dividing by 2/3, which is really multiplying by the reciprocal. Or I can eliminate the fraction first. I could multiply both sides by 3 first. So we get 2x equals 420. And now to get x by itself, since it's multiplication, I can divide both sides by 2. And x equals 240. But remember, that was dollars. And we can plug all that back in and check our work as well. Okay, for example 5, I can barely see it. It's squished down here. If 2x plus 13 equals 17, find the value of 3x plus 1. Well, we need to know what x is first in order to find the value of anything. So let's solve for x first. So I'm going to highlight my 2x. To get rid of the plus 13, I'm going to subtract 13 from both sides. I get 2x equals 4. To get x by itself now, to get rid of multiplication of 2, I'm going to divide both sides by 2. And x is 2. So now that I know that x is 2, if I plug the 2 in right here, I would get 3 times 2 is 6 plus 1 is 7. Okay, in example B, I'm going to solve this one now. So I can't add y plus 10 in the parentheses there, so I'm going to use distributive property. 5y plus 5 times 10 is 50 is equal to 40. Now I'm going to highlight my 5y. In order to get rid of that 50, I'm going to subtract 50 from both sides. I get 5y equals negative 10. To get the y by itself, divide both sides by 5, and I get y equals negative 2. Now to find the value of 1/4 of y, I'm going to plug that right into the y value. So 1/4 of negative 2. Remember, that's negative 2 over 1. I can cross simplify, and I can multiply straight across. 1 times negative 1 is negative 1 over 2 times 1 is 2. So negative 1 over 2 is my final answer. Negative 1/2, I should say.